Alright, howdy. We're going to try this again. I tried this once. For those that may have missed the notes that we took today, we kind of sped through the notes at the very end. So I want to go over a couple things with you. First of all, the second half of class, we watched the video. Any videos that I show in class or do through this recorder will be posted on my YouTube channel per unit. So here you see the Intro to Physics YouTube channel, and once I get this video done, I will post it, and it will be the third one in the list. This is the one we watched, the Atlantic Pacific Rule of Significant Digits. The idea behind the Atlantic Pacific Rule is for you kind of to think like the direction you count. So like if you were in the Pacific Ocean, if you were out swimming in California, to get back to shore, you would swim to the east or to the right. And if you were out in the Atlantic, you're out in North Carolina or Florida on the Atlantic side, you would swim back to the west or back to your left if you're looking at the United States. And that is also how you count your digits. If you're still confused, this is a nice one. I may assign it for homework later, but it's crash courses in chemistry. Okay, so that's there. Other things, I assigned you guys, if you picked up the wrong one, make sure you go back and either get the right copy from me or print this copy. I will not accept an emailed version of this. You must do it on yourself by hand. And here it is. It's Physics Math Practice Packet pages 1 and 2. And the link is there, but I will not accept a hard copy. So please, I tell you this, I'm giving you a hard copy in class. If you picked up Mr. Tita's graphing one, please, you can do it. I don't know if I'm going to assign that one. You're more than welcome to do it, but we haven't talked about that in class. Alright, so significant figures for the notes that we didn't quite get finished up. We have the definition of significant figures. What you guys need to do is understand how to add and subtract, multiply and divide them. So what I would like you to do so remember significant figures, the Atlantic Pacific rule we talked about. Oops, got my sides messed up. How about I mess up a couple more times? Okay, so we have our Atlantic Pacific rule. Ultimately, that just states if you're working from the Pacific side, that means there is the presence of a decimal. Okay, if you're working from the Atlantic side, that means the decimal is absent. And you're going to count the direction you would swim to get to shore. Okay, so if the United States were here, don't judge my United States, there it is. That would be the direction you move when looking at your decimals. And A corresponds with absent, Atlantic, absent decimal, Pacific, present decimal. Okay, so you have that. You have the number 4.367 because the decimal is present. I'll put a 0 in here. You're going to count this direction. 1, 2, 3, 4, 5. 5 significant figures. Okay, if we have 230,170, you realize the decimal is absent, so you skip this 0. He's not important. You count this direction. 1, 2, 3, 4, 5. Okay, now I skipped ahead on you, which was not my intention. So adding and subtracting. Adding and subtracting. I need this to scroll down. Okay, when you add and subtract your decimals, pay attention carefully. You are to go with the least amount of decimal points. Yeah, you do least amount of decimals. Sorry, I'm writing sloppy. I'm writing quickly here. Okay, least amount of decimals. So if you have 4.32 0.268 plus 3.1. There's one decimal place there. That's the most amount of decimal places that you can go in this case. You're looking at whatever the least accurate measurement is. So if you're measuring with a ruler without inches on it, then you're going to have to get as accurate as you can. That's kind of why we did this measurement activity. We're looking at the least accurate measurement. So if you measure the height of a desk at being 3 feet 2 inches tall, all right? But then you measure the height of the chair that goes with it. If you sat the chair on top of the desk and you want to get the total height, you only measure the chair and you measured the chair more specifically. So 3 feet 2 and 6/16 inches. Okay, well, you don't know the exact specifics of the table. You don't know the 16ths. You don't know the parts of an inch. So you have to go with the least accurate. So when you add this, it theoretically would be 7.4268, right? Well, you have to go with the least accurate measurement scientifically, so it would be 7.4. That's the best you can do. Now, when it comes to multiplying and dividing, this is the least amount of significant figures. The same story happens if you have a significant figure. You measured something like to the nanometer, like you were so perfectly exact on measuring something, and you figured out the amount was 2.634857, or like you're using pi to the nth decimal, but then you're multiplying it by something that's 1.3. There are only 2 significant figures here. That's the most amount of accuracy you had. So when you're taking both of those numbers, you can only rely on that one, the least accurate number. So again, if I take this and I multiply, and absolutely feel free to pull out a calculator when you work through these. 2.634857 times 1.3. That results in the number 3.4253141. Wow, big old number there. Yep, but because this was so inaccurate, you can only use 2 significant figures. So there's no rounding that has to occur here. You just have 3.42. Nope, yeah, 3.4. Because the 2 was the next number, so you don't need to round. That is how we do this. Alright, so real quick, I'm going to do some examples on your homework. So I have some examples already done, so I'll just walk you through them. Okay, so the first part is just counting significant figures. I need to double check on when we're using scientific notation. I kind of, based on the Atlantic Pacific rule, I think I kind of explained this wrong. So this could either be 3 significant figures, but I think because a decimal is present, there's actually 1, 2, 3, plus 1, 2. I don't know. I need to address this, so let that lie for a minute. I need to double check with another source to make sure I'm teaching this part correctly. Okay, now when it comes to here, we have an adding situation. You see I circled this one. You don't have to do this. I'm just showing this to you. Adding, it want 1 decimal place. So the best you can do is 1 decimal place. Here's the actual answer. Notice the 5 will round this up to 10. So that would bump up this number and leave this as a 0. So negative 142.0 would be your answer for here. And yes, please feel free to do the calculations. Here, multiplication and dividing. This has 6 significant figures, 3 and 5. All right, so when you do the math, this is the number you get right here. Great. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 significant figures. The most accurate, or the least accurate number you have is 4.08, 3 significant figures. So this is the best you can give. All right, scientific notation. I'm moving on, moving quickly. So if you needed to see that again, rewind, pause, whatever. Okay, here, you move your decimal place till it's the first number and a decimal point. All right, so this would be 1.02, and you move the decimal place 1 point to the left, so times 10 to the 1. All right, because it only moved one place. You're telling them the answer was 10.2. Okay. When you're moving this direction to your right, it's a negative. All right, you're going a negative amount because that's how small the number is. So negative fourth, 1.30 times 10 to the negative fourth. And here you just work out the opposite way. Think about, okay, negative 2. That means I'm going to go the opposite of this. Move 2 decimal places, and it's 0.0496 was your answer. Okay, and the last one is figure out where the mistakes were. So just put them in correct scientific notation. All right, I'm stopping there. Hope it helped.